Hello and welcome everybody to the subject of drum brakes. Drum brakes, a little bit of a review, involve the wheel cylinder as the hydraulic component that helps apply our friction material. Our friction material is in the shape of what's called a shoe. This is a brake shoe. There's a friction lining on it. It's mounted to a steel backing, and this is mounted onto the assembly. There's a few unique features about drum brakes. One is that they offer more stopping power compared to the same size of a disc brake. Our friction material is going to engage a friction surface on the inside of a drum. So this is going to be a cast iron machinable surface. If we have aluminum drums or steel drums, this will be cast iron. As the friction material presses against that inside surface as the drum is rotating, the shoe is going to try to rotate with the drum. What this does is it offers a self-energizing action because of the parts inside the drum assembly that keep the shoe from turning with the drum. So our brakes apply our shoes outward, the rotation of the drum grabs onto those shoes, and those shoes want to turn with the drum. The anchor on the backing plate is going to stop that movement from occurring, and then our friction surface is going to apply even harder as it wedges into the rotation of the drum. This is known as self-energizing action. And across the different types of drum brake design, there is always an element of self-energizing action. Many of the drum brakes that you'll see will not be on the front of a vehicle. If you're working on an old enough vehicle, you may come across it. But the drum brake design is susceptible to varying amounts of stopping power when they're applied. And that has to do more with left side to right side. So if we have more braking happening on one side than the other, then the vehicle is going to pull to the side that has more braking power if it's on the front. So typically vehicles will have disc brakes on the front, and if they don't have disc brakes in the rear, they will have drum brakes, pretty much only in the rear at this time. Let's take a closer look at the drum brake assembly and its components. So on the outside is our drum. Our drum covers and contains all of the braking assembly. It's all inside and housed within this drum. Everything mounts to what's called the backing plate. Removal of the drum. Our backing plate here surrounds the entire assembly and is made of a thicker gauge metal, and it actually has a lot of strength properties to it. This is actually supporting the load of stopping that tire's rotation, or slowing that vehicle's rotation down at the wheel, and it has to be able to withstand those different forces. So this is going to be a pretty stout component of the drum brake assembly. Inside, mounted to the backing plate, is our wheel cylinder, which you're all familiar with at this point. This is our brake adjuster. We have an anchor down here, and this is known as a keystone anchor. And this type of brake assembly that you're looking at here is a non-servo brake assembly. We have springs that help pull the shoes away from the friction surface of the drum so they don't drag and contribute to poor fuel economy or poor drivability or overheating of the brakes or premature wear of the brakes. We also have a spring down here holding the bottom together. We have hold down springs that anchor the middle of our shoes to the backing plate. And these have some give in them, so it allows some movement of the drum brake assemblies. And then not shown in this example, it would come through right here and cross over to this side and attach to this lever. This lever right here is the parking brake lever. Another part about drum brakes is the drum themselves. Now these are usually going to be a steel cast iron with some fins. Fins help in cooling. They help release some of that stored up heat that's being transferred into the metal from the friction surface. They're very much like a bell shape, and they should ring like a bell. If this were to have a dead ring, if the ring were to terminate quickly, we can assume that there might be a crack somewhere in the drum. Our friction surface is a mating surface that has to be machined and mated to our friction material. These wear together, and in order to have optimum braking performance, we need a consistent, even diameter or circle dimension around this friction surface here, and smooth contact with the friction lining. So that surface needs to be as smooth as possible. The purpose of our brake adjuster assembly, which goes in between the shoes here, through the function of the brakes operating the adjuster as the brakes wear over time, it helps to hold the brake shoes farther and farther out in their resting position so they remain nice and close to the friction surface they need to work against. Drum brakes are susceptible to certain types of brake fade. Brake fade is when you are applying the brakes for a sustained amount of time, and as the brakes overheat, the brake pedal, no matter how much more pressure you put on it, does not help stop the vehicle any better or more efficiently. And sometimes brake fade can lead to the pedal sinking, and other times the brake fade can lead to the pedal getting harder. In this case, if the drum were to heat up enough, we have expansion as those molecules are moving faster and faster. The slight expansion that the drum can experience brings it out away from our friction material. And that would cause the brakes to reach their limit and not be able to apply efficiently. So that's a mechanical fade. The next type of fade is a lining fade. This has to do with our brake shoe lining. And this friction surface has a rated friction coefficient of friction at a cold temperature and at an operating or hot temperature. If we exceed the hot temperature rating, this coefficient of friction will likely drop. Many shoe linings are the same rating for cold and hot, but if they get too hot, that coefficient of friction will drop. As that coefficient of friction drops, our braking ability goes down. And no matter how much more pressure you put on the brakes, it's not going to make it stop any better. The next type of fade is gas fade. Gas fade occurs when the friction lining can get hot enough to where it starts emitting a gas. And that gas acts like that air hockey table and that hockey puck and helps let this slide by without applying the brakes. The last type of fade is water fade. Standing water, water being sprayed into the wheel or up from a car wash or some other place, water can get into the drum brake assembly. In order to help prevent dirt, mud, water, contaminants from getting into the drum brake assembly, there's what's called the labyrinth seal. So this groove all the way around the drum here sits over this lip. So inside here is a space where the drum would fit into. And what it's creating is an indirect path for those two pieces to rotate without touching each other, but any dirt and contaminants would have to find its way into the drum brake assembly after navigating through the labyrinth seal. So there's no direct path for water, dirt, mud, and contaminants to get in. If they do, they can get onto the friction linings and cause brake fade due to water. Now let's go over a couple of the components in the shoe assembly. The brake shoe assembly is made out of a steel backing and a friction liner. The friction lining is a softer material and it's designed to wear faster than the drum surface. So giving the structural integrity to the shoe assembly is this perpendicular piece called the webbing. The webbing is what engages the different components like the adjusters and the wheel cylinder and has anchor points for springs. The inside portion of this that the friction lining is mounted to is our lining table. Now along the lining table, you see these little raised areas and these little kinks. These are what are called the nibs, and these nibs ride on pads on the backing plate surface to help smooth operation and keep them from rattling around and moving around. So they are anchored against pads that allow it to slide and slip against. Then we have our friction lining, and these, you can see here in these holes, are riveted to the lining table. There's the inside of the rivet. Now, rivets can be made out of things like brass or copper, and they are mechanically clamping the friction lining to the shoe. By introducing these holes into the lining, we can develop problems like cracking. And those cracks will generally form in between those stress points that have been created by putting the rivets in there or having holes. If you find a lining that is cracked, it needs to be replaced. And when we're working on a lot of the chassis systems underneath the vehicle, you don't replace just one side or one corner, you replace them in axle pairs. Here's an example of a brake shoe friction lining that would be riveted to the shoe. Bonded brake shoes don't have rivets anchoring the friction lining to the lining table. That bonding can fail and allow the friction lining to come detached from the brake shoe assembly. Also, when it comes to riveted versus non-riveted, these are a very similar thickness. But we only have, on the riveted assembly, we only have the amount of friction material until we reach the rivets before these are worn out and need to be replaced. On the bonded friction material, these can wear down almost to the lining table before they need to be replaced. In this example, we can measure the lining thickness .99 millimeters, pretty much 5 millimeters. However, if we measure our thickness down to the rivets, we actually have a usable friction surface of just shy of 2 millimeters, so 1.95 millimeters from the surface of that friction material to a rivet. When measuring brake friction material, if it's thinner in one area compared to another area, the measurement will always be taken at the thinnest point. So on this one, I don't know if you can tell from the video, but this one's thinner in the middle than it is on the end. So we would measure the thickness at the middle. If we were doing a brake inspection on the entire vehicle, we would take the thinnest measurement of the rear brakes collectively and the thinnest measurement of the front brakes collectively. If we get some large differences from one shoe to another, then we might have an issue with premature wear of a component or something is sticking. This drum brake is off of a 1995 Dodge Dakota. This is an example of the dual servo drum brake design. The dual servo, or you may see it written as duo servo. Duo servo is a brand name from the Bendix Brake Corporation. The dual servo brake action occurs from the rotation of the drum helping to self-energize the brakes. We have that wedging action that occurs when the friction surface tries to rotate with the drum. The direction of rotation going forward is this way. So look at that drawing in the background there. That's our direction of rotation for this assembly. As our shoes apply at the wheel cylinder, they're going to move outward. As the linings move outward, that forward rotation of the drum is going to grab this assembly and push it. See how this actuates from one side to the other? So that drum is using self-energizing action to serve from the primary shoe to the secondary shoe. The primary shoe is our forward-facing shoe. And what's happening is taking that rotation and helping to apply the rear or secondary shoe. A couple of things to note here. Our friction lining on the primary goes from here to here. Our friction lining on the secondary is almost the entire length of the shoe. In these assemblies, in a dual servo brake assembly, the secondary shoe is doing 70% of the stopping power. The primary shoe is helping to apply that secondary shoe through self-energizing dual servo action. One of the main things about a dual servo brake assembly is where the anchor is located. The anchor is the portion of the backing plate that rotational energy is being stopped by or resisted by. On a dual servo brake assembly, our anchor is going to be near the wheel cylinder. So in this case, we have our anchor above the wheel cylinder and the wheel cylinder just below that. Opposite from the anchor in the wheel cylinder is the brake adjuster. And the brake adjuster is acting like a strut in between the bottoms of those shoes, keeping them adjusted to the right clearance. The orange is representing our friction material. The black part here is our shoe. And then if we zoom in, here is our drum on the outside, and the orange is our friction material. Orange is our friction material, the black part's the drum on the other side, rotating forward in this direction. As the wheel cylinder pushes outward, it's going to force these shoes out against the drum surface. As this gap closes up here at the rotating surface of the drum, that drum is going to grab and try to rotate. It's going to grab and try to rotate that friction material downward and force this shoe this direction. With our adjuster at the bottom, this energy that's pushing down into that primary shoe is going to transfer to this shoe, which is our secondary shoe. This secondary shoe is going to come up and wedge into that rotating drum. As that happens, our brake force is going to spike. This is why we need proportioning valves, because once this occurs at a certain pressure, we don't need very much more pressure to maintain a fixed level of stopping power. So our proportioning valve is going to limit, at the split point, is going to limit how much pressure is coming up to the wheel cylinder to help apply those shoes against the rotating drum. Then once the brakes are released, the mechanical springs pull everything back inward, away from the friction surface, and everything rotates freely again. When we're moving in reverse, the same action occurs but in the opposite direction. 99% of the time the vehicle is driving forward. That's why our friction material on the primary, the forward facing, is smaller than the rear facing or the secondary. And as the secondary shoe is applied, it transfers that servo action into the primary shoe, and the primary shoe is what's giving us our self-energizing stopping force. With the smaller friction material up front, it doesn't produce as much stopping power, but we don't need as much stopping power when we are going in reverse. The other main component to drum brakes is the use of a parking brake. Since it doesn't take a lot of effort to establish a good amount of stopping force, either foot lever or hand brake can help apply these brakes to keep it stationary, and it's going to hold a heavy vehicle forward or reverse. The other type of drum brake configuration is called non-servo. This is identified by locating the anchor point in relationship to the wheel cylinder. In this example, the wheel cylinder up here is on the top again, and our anchor is on the bottom, so it's opposite from the wheel cylinder. Now remember, the anchor is resisting that rotational force. It's what gives our servo action something to wedge against on our duo servo brakes. It's also going to provide an anchor point to wedge against in a non-servo application. Now the main difference is that we do not have servo action. We don't have one shoe acting on the other shoe. We have them separated to where they operate independently from each other. The text also mentions that this is a keystone shape, meaning it's tapered on the sides, where the shoes contact that taper allows them to ride up and down and center themselves with the rotation of the drum. As the drum is rotating, again in the forward direction here, the wheel cylinder is going to press outward on the shoes. As the rotation of the drum continues this direction, it's going to grab the leading shoe, which is our forward-facing shoe, and it's going to wedge that shoe against the anchor. The hydraulic pressure applying the trailing shoe is evenly distributed between the leading and the trailing shoe. The trailing shoe is going to make some contact with the drum, but the drum rotation is trying to push it back in towards that wheel cylinder. We're not going to get that wedging factor or that self-energizing action on the trailing shoe on a non-servo brake. We do, however, get it on the leading shoe. So the shoes on non-servo brakes are the one towards the front is the leading shoe, the one towards the rear is the trailing shoe. So again, as this occurs, our rotation of the drum is going to help force down and inward on that shoe. As that downward and inward force is energizing from the rotation of the drum, it's stopped by our anchor. That anchor is going to stop the shoe, and this is going to create a wedge action. So self-energizing action on both duo servo brakes and on non-servo brakes. On duo servo, we have one acting on the other. It serves the other shoe, so we have duo servo action happening, and that creates our self-energizing action. And on non-servo brakes, it's only happening on one shoe at a time. So if we were to apply the brakes in reverse, our self-energizing action would occur on the trailing shoe or the rear shoe on a non-servo setup. The little bit of friction material that's contacting the surface of the drum is still going to help, but it's not going to be providing as much stopping force as the shoe that's being wedged against the anchor. So we want to pay attention to where's the wheel cylinder, where's the anchor. Brake drums, for as simple as they are, can differ in design. They're also going to provide us with some information that we can use. On some of them, they'll actually have a part number. This one is a Bosch part number, 024-212-022. That can usually be cross-referenced with a parts dealership or a parts store to find a good aftermarket drum to replace it. There's also a specification here for max drum diameter, and this is given in millimeters at 226.55 millimeters. Our maximum diameter has to do with how much material we can remove from the inside of this. This drum is held in place by the wheel and the lug nuts fastening it against the hub or the axle in order for it to engage the axle and rotate with the wheel. Once the wheel is removed, the drum can be removed from the assembly without removing any other hardware. As the brakes wear, our shoes will wear into this surface, and since they don't ride all the way out to the edge, there can be a lip here where the shoe can catch when you're trying to pull the drum off, and the shoe is actually recessed into the surface a little bit. At that point, the brakes may need to be adjusted to the point where the shoes come in far enough, and then the drum can clear the shoes and come off the brake assembly. As the brakes wear, the adjuster compensates for that wear and sits farther and farther apart, helping to keep these shoes close to the drum friction surface. If we cannot get the drum off of the brake assembly because it's catching on these shoes, and that lip will actually catch on this inside edge of the shoe, if we have to bring these together, we have to access that through the rear side of the backing plate. There's usually an oval hole near the adjuster assembly where tools can be placed through, and this would be done to help push the tab back, and you might have to work with a couple different tools, But by doing so, we can unadjust our brake assembly and free the drum from the brake assembly so we can work on the rest of the system. Some drum designs will have threaded holes on the face of the hub mounting flange. So there'd usually be one here and directly across one over here, where you could thread a bolt into it, and that bolt would come through and help push on the hub surface to push this off of the brake assembly. The other type of drum may be fixed with a hub. This has a pressed-in bearing inside of it, and this drum, as you can see, has wheel studs that the wheel bolts to. So this has an integrated hub design. This one has a bearing that would be serviced by pressing it out. There's a snap ring that's helping to retain it in here. This snap ring would have to come out of the groove before that bearing is removed. On some vehicles, the drum may require further disassembly in order to remove it from the vehicle. Similarly to the previous example, this one is also held on by a spindle and hub assembly. We have to disassemble the bearing that's sitting on the spindle. There's a cotter pin used as a safety piece to keep the nut from backing off. As we remove this, it doesn't matter if you just installed it, the cotter pin gets thrown away and we put a new one on. As the cotter pin passes through the spindle and locks between these tabs, it also helps retain the nut. So if the nut were to come loose, this is a safety device to keep it from coming off or backing all the way out. Unthread the spindle nut. Spindle nut comes off. And then the drum can be removed. This is our spindle. This has mounting surfaces for bearings, an inner bearing and an outer wheel bearing. The wheel bearings will often need to be serviced at the same time that the drum is removed to inspect or service the brakes. This is an example of a full floating axle drum brake assembly. Similar to the bearing and spindle design drum brakes, this also has a spindle and bearings supporting the rotational movement and the load of the drum brakes. Now this is going to be found on a heavy duty application. This has a large hub center and it has 8 lugs for the wheel studs. This is going to be off of a full-size truck or a large heavy duty chassis application. Very large, very heavy. So right here, this portion right here is our axle housing. So on the older designs, the drum is going to be captive with the hub. On newer models, this may not be captive to the hub itself, but you may come across this. There will be 8 axle flange bolts holding this in. And this right here is our drive axle. So the drive axle is being driven from the differential out to the hub, and these bolts, 8 of them, are transferring that torque force from the axle flange into the hub. Then the axle shaft can be removed. And then we have a couple retainers inside here. So the spindle, in this case, is this portion right here, which is the axle housing itself. In order to remove this, a special socket, or sometimes a drift punch, since I don't have this special socket, I'm going to tap on this ring, this retainer lock ring, to help spin it off of the threads. And there is a second one behind that that is keeping our preload on the wheel bearings. At this point, the whole drum and hub assembly come off as one heavy unit. Inside the hub, we have our inner wheel bearing, we have a seal, and we have our outer wheel bearing. Those, again, may need to be serviced at this time. So the question is, what kind of brake assembly are we working on? It's duo servo brake assembly. So we have servo action. These are riveted brake shoe linings. Very heavy duty setup. Things are going to be heavy, may not want to move easily. It's going to require some extra force to work on an assembly like this. The last part of this video, I'm going to show you how to service drum brakes and the assemblies. Starting with a couple tools. This tool is similar to one that you have in your toolkit. You may have one that has a scissor pivoting portion in the front or in the middle with a hook spring on it. I prefer this style. It's simpler, no moving parts, and it doesn't have anything sharp and pokey on it. These have to do with being able to remove and install springs. So the first thing I'm going to do is take this tab end here, and notice that the center of this is hollow. I'm going to rotate that tab end around the inside of the hook of a spring. This spring is sitting the farthest out, so what I'm going to do is position that over the anchor, and I'm going to rotate that tab underneath the inside of that spring hook. And once I have it on the outside, I can pry it away, and I've removed my spring. It helps if you take a picture of the assembly before you disassemble it, until you get the process down to know exactly where things go. Do the same thing for the other spring on the other side. And this piece here helps guide our parking brake cable over to the lever. And this has a little piece on the back side of it that helps center it in this hole where the spring anchors it. Remove our adjuster and the retaining spring for the adjuster. Now here's a hot tip. Take some C-clamps and clamp it to the backing plate behind the shoe. That way when you're pulling on these springs, the shoe will butt up against that anchor, the shoe will butt up against that clamp, and it won't try to slide off. Mostly what you're trying to avoid is pushing one end of the wheel cylinder out from the opposite side. Then you would lose brake fluid, and then you may be opening the system unintentionally. Bottom spring removed. This is our parking brake strut. Then we'll use this tool, which has little areas that you can see into, to help remove our hold down springs. And as you disassemble, things may start disassembling themselves before you're ready. When we're using the spring tool, what we're doing is depressing this spring from the front of the brake shoe. This tool has little teeth on the inside of it, and when you fit it over these and you press, you can then rotate the assembly. The reason why you need to rotate it is because the profile of the pin, the hold down pin, has a little T shape on the top. And that T shape has to fit through that spring retainer, and then the spring retainer rotates 90 degrees and it locks in place. So in order to remove them, we have to depress the spring, rotate it, and come off. This also requires holding it from the back side. So where our pins come through, they don't stay there by themselves. If you hold them flat in the back with some pressure on the back, it takes a hand, then you can work on the front side of them. Here's our wheel cylinder, here's our anchor. We can detach, if we needed to, we can detach our parking brake lever. Not necessary on this application. The next thing we need to do is make sure everything is clean. I'm going to use my brake clean in the Sure Shot container. Spray it on a rag. Wipe off any grease. So these pads that I just cleaned off are what contact our nibs. And on these brake shoes, our nibs are actually bent over along the outside of the lining table surface. And that's what contacts those pads on the backing plate. These pads need to be cleaned with emery cloth or an abrasive wheel. With the pads nice and cleaned and polished, I'm using a ceramic silicone. And you want to fill in those grooves and provide something that's going to keep it from rusting, and to provide lubrication for those nibs to ride against. Being close to the friction material, we have to be careful not to put too much grease on here. If we have too much lubricant, it can get onto the brake friction material, and anytime there's lubricant on friction material, it's not a good thing. We want that friction material nice and clean so it can do its job. If we got any excess grease onto a surface where we don't want it, now is the time to wipe that down so it's only where it's supposed to be. So now you can see all of our pads have been polished clean, removed of any old grease, and greased for installation with new lubricant. The brake adjuster also needs to be serviced. One side may have reverse threads than the other, so this one is actually being removed by rotating it clockwise. So this has reverse threads on it, or left-hand threads. Dirt and grime and brake dust can get in here and seize them up. Water can also get in here and rust them. It doesn't matter if this was just done by somebody else. The only way to know that it's been done correctly is to do it ourselves. So there will be no cutting corners on servicing of the systems, especially the brakes. So that's ready to go back together. Last thing we need is our brake parts lubricant to keep everything moving nice and smoothly. And to make reassembly of the brakes easier, we'll bring this to the all the way in position. So it's not trying to spread the brake shoes apart at all. And once we get it down to the end there, give it a few back and forths to evenly distribute some of that lubricant. And then wipe that clean. And as I push this piece together, I want to rotate it at the same time to help distribute that grease to the contact area. And then again, wipe the excess off to limit the chance of brake grease or the lubricant getting onto the brake friction material. This is the front of the vehicle, or front of the backing plate. I can tell that because the parking brake cable is coming in from the front of the vehicle. So wherever the parking brake is, whether it's foot operated by the driver or hand operated by the driver, it's coming from the front and it's going to enter the backing plate from the front of the vehicle. So this is the front. We'll get our hold down pin through the hole. Another tip here using clamps might help you in the future by using a larger C-clamp. We keep these in the tool room. You just need to check them out. And you can actually place these where they belong, just like that, and they can be clamped in place. When you only have two hands, this can be tricky to set up and have everything held in the right spot. Once we install our hold down, we can release the clamp and do the other shoe. Put our shoe retainer up around the anchor. Put our star wheel adjuster in at the bottom. When we're working with brake assemblies and the brake shoes, any friction material for that matter, we must be very conscious of this clean friction material here. If we get any contaminants on that surface, it needs to be cleaned. And if we clean it with something like brake clean, that can actually get in to the resins inside of the friction material that bond it together, and some of that bonding material against the webbing in the backing plate here. And that brake part solvent can get into these bonded linings and actually cause that adhesive to wear down, or those resins to break down. So first goal is to not get them dirty. second goal is to clean them as little as possible. Each time everything kind of falls out of its position, I want to make sure that it goes back to where it's supposed to be before I move forward. Now I'm going to use the other end of this tool. This end of the tool was rotated around to help pry the hook off, the spring hook off of the retainer or off of the anchor. This end is going to be used to install it. So the spring will actually hook around the back side of this where it is bent upward, and the underside will hook onto the anchor, and as I lift this end of it, it will help that spring slide onto the anchor. Then I'm going to do the same with this spring from the other side. So again, up close, this spring is going to be hooked around this tool, and then this tool is going to hook onto the anchor. And with this end of the spring in its hole, as I lever this up, it's going to help that spring slide down onto the anchor. Doesn't always go on first try. I forgot a piece. Had to go back. Take that spring off. Take that spring off. This needs to go on before those springs go on. Now, we'll put these on. Should have taken a picture of it. Would have known. Route that around the cable. So here's our hook, and it needs to engage right here on this piece. Sometimes you can just lift that up high enough. In most cases, these shoes are being replaced with new friction material, so the friction material is thicker, and our drum surface might have been machined to a nicer finished surface. If that's the case, then we have more diameter here, and we have a change in our thickness of material here. So the adjuster should be brought in to where these are as close together as possible. And to check the fitment of the drum, we use one of these gauges. The distance in between these two surfaces right here is the same as the distance to these 2 points here. So if we bring this out to the same depth on the drum surface, we can actually get this really close. And then we can check our adjustment before putting the drum on. Once we get our adjustment correct, the drum can go on, and it should have a very light resistance to it. You should only hear it skimming the surface of the shoes. We don't have a hub on this setup. In order to get this adjusted correctly, it would need to be mounted on the vehicle or on the hub. So that's drum brake service for one side. Drum brakes have a lot of mechanical pieces to them, and oftentimes people are deterred from working on them because of their seeming complexity. If you take pictures and you look up service information and you pay attention to where things were before you took it apart, and use that as a reference before you go back together, it's going to help you a lot in the long run. And once you cruise through a few of these, it's going to become a lot easier to work on and service drum brakes. You will see them. They're still out on vehicles today. Keep this in mind. I hope you got something from it, and I hope you can apply it to working hands-on when we're in person, going through the different lab activities and servicing drum brakes. Thank you.